thought up some improvements to Salsa, so I will expound upon those right now. If you recall, Salsa is spontaneous application layer security addendum. What that means is the security goes all the way to the application that you're interacting with. Normally, TLS, what we think of as very good internet security, will get you to the front of the building, and then within that, anything goes. There could be insiders lurking and watching the data, could be anything. Out on the internet, of course, it's going to be pretty safe, but on the inside of your organization that you're that is publishing the web application that you're consuming, there is a lack of security. So I came up with Salsa, and that is basically an extra layer inside of the data that we're used to. So if you get to the think of interaction like this, out in the internet, it's going to be secure due to TLS, transport layer security. Then you'll have a entryway here. They call it like an API proxy or whatever. Then on the inside, it's not necessarily very secure. So I feel that that should also be secure, and they do TLS with certificates. And what happens is this part will send back a certificate that can be verified with an alternative third-party certificate authority, and to make sure that you're interacting with that organization. So extending that theme onto Salsa, and the reason you would have a second version of that where you would send a certificate out, but this one has to be spontaneous. And the reason why this it can't be set in stone, chisel in stone, is that eventually insiders in the business, there's typically thousands of technology workers inside of a very large organization, are going to become privy to that secret key, and they will be able to eavesdrop on this data. So it has to be spontaneous. A machine will have to make up a key, a secret key, and they will have a certificate, and you will need to verify that you're interacting not with the building, not just with the organization, but also with software that you hope to be interacting with, and it needs to be encrypted. So how do you do that? You spontaneously make up a secret key, you'll make up a public key certificate, and that will be certified by this part, and you know that you're dealing with this part because of the TLS and the initial long-term certificate public infrastructure. So what you will do is create spontaneous keys very often, and not only that, you'll keep them secure from prying eyes. Basically, you'll have a lot of tech people, they just won't be able to see it, and they also won't be able to see what happens inside this program. And you'll use that to negotiate a private key that will make this blind to anybody who works at the business. You can certify a certain few people who can get on this part of the software and do any kind of work that needs to be done to it. And then you'll also do that with the persistence, the database layer. And you'll also want to segment identity type information. Put a layer of, it's not a layer, put a what do you call a reference layer between actual identity information, such as your social security number, your phone number, emails, full name, email address, and the data that you're putting in the machine. And I already discussed that. So, but the crux of this improvement is that the organization itself will serve as its own internal certificate authority, and you will know you're dealing with that certificate authority because they will also have an external certificate authority verify that you're dealing with the organization, and you will just need to make sure that this certificate gets to here in a secure fashion and that this secret key stayed out of sight from the bulk of the technicians in the business. That is all.